This lecture video is pretty short. It's about temperature. We've already done a Bunsen burner lab where we have looked at measuring the temperature change of water over time based on different positions of a beaker away from a Bunsen burner flame. Okay, so what is temperature? This is something that's considered a relative measurement. A relative measurement is one that has specific units with it. It is a graded scale. Temperature can be defined as the measure of the amount of heat energy within an object. Okay, what does that mean? We know that we can have a container that has some type of water molecules in it. And we know, like for our Bunsen burner activity, before we took a pre-temperature or a starting temperature, baseline temperature, and you all had some pretty good consistent temperatures. And with this, the water molecules are just moving around each other, just moving, just grooving, like they're walking through the mall. Okay. When we added the flame from the Bunsen burner here, we're increasing the amount of heat energy within this substance, and these water molecules start moving like a crazy person on their way to get a new pair of Jordans. They're trying to beat the line to get the brand new pair of Jordans that dropped today. Okay, does that make sense? They're moving fast. They're still moving past each other, but we go from being unheated, just at room temperature, the particles are moving really gently. As we add heat, we're adding energy to this system from the surroundings. Those particles start moving really crazy, okay? Even crazier, as we continue to add heat, if we went the opposite direction from room temperature and we started to go through the process of freezing, these particles that were just moving around like this, they start to move more slowly, okay? So we have to understand that there are 3 temperature scales. I know this is a lot of information, and that's okay, but we do have 3 temperature scales. The first one is Fahrenheit, the second is Celsius, and the other is Kelvin. So let's focus on Fahrenheit first, okay? The Fahrenheit scale is what we commonly use here in the United States. This was originally based on like an ice, water, and salt mixture. They did change that to make it just a water mixture, or look at how ice water changes. Fahrenheit has some different temperatures in here, so typically we like to say our normal body temperature is 98.6 degrees Fahrenheit, or they'll say 98.7. Average room temperature in Fahrenheit is 77 degrees Fahrenheit. The freezing point on the Fahrenheit scale is 32 degrees. Maybe when you were in elementary school, they would say we cannot go outside if the temperature is below 40. That's what my elementary teachers would say, because that's too close to freezing. The boiling temperature of water is 212 degrees Fahrenheit. That's when water starts to vaporize. If you play baseball or softball, and you go inside of the facility across the street, you see 212 on a banner, and so that's the boiling point of water. Don't let anyone confuse you. Celsius, it's designated with a C with a little degree mark. This is based on water, just basic water temperature. There was nothing with salt water. You will see that it varies. The freezing point in Celsius is 0 degrees. The boiling point is 100 degrees Celsius. Average body temperature is 37 degrees Celsius. Room temperature is 25 degrees Celsius. Okay? This is what we commonly use in the metric system. The thermometers that you have in our class measure in degrees Celsius. Okay? The Kelvin scale is something that you may have never used before in physical science. You probably studied this a little bit. Kelvin is based on a value called absolute zero, and so they are saying that absolute zero is where all molecular motion stops. So the freezing point on the Kelvin scale is 273.15 Kelvin. The boiling point is 373.15 Kelvin. We like to say that normal body temperature is 310.5 degrees Kelvin, and then the average room temperature is 298.5 Kelvin. Okay, and you're probably thinking, what do all of these numbers mean to me? All right, we have some mathematical conversions, because that's what we're going to focus on, is can we convert between one scale to another, or from one scale to another, between 2 different scales, okay? There are some formulas that take us from Fahrenheit to Celsius. So if I want to have an answer in Celsius, I would use this formula. I use my Fahrenheit, subtract 32 from it, and divide that by 1.8. If I want to go from Fahrenheit to Kelvin, Fahrenheit is what we know. We plug that into the formula, your Fahrenheit minus 32 times 5/9, or 5/9, add 273.15 to it. These are two formulas to solve from Fahrenheit to another scale. You might want to pause your video and mark these down. Two formulas to go from Celsius to another temperature scale, Celsius to Fahrenheit, Celsius to Kelvin. If I want to go from Celsius to Fahrenheit, I want to do C times 1.8, add 32 degrees to it. From Celsius to Kelvin, it's C plus 273.15. You'll notice that going from Celsius or that metric system to the Kelvin scale is also, pretty straightforward. To go from Kelvin to Fahrenheit, we're doing pretty much the opposite of what we had done above. Kelvin minus 273.15 times 5/9, because remember before it was 5/9, and you add 32 to it. And then to go from Kelvin to Celsius, Kelvin minus 273.15. Okay? We are going to use these to do some conversions, so you might want to back up your video and mark those formulas down.